Hey Expo Algebra, this is Mr. Monahan here for 9.2b. Today we're looking to continue our discussion on how to graph parabolas, but we're also going to look at some word problems that maybe give you more of a real-world taste on some of these things that we are doing. So today we're going to apply properties of quadratics to solve real-world problems. Before we get there, very quick review of the difference when there's only a binomial versus a trinomial when you're trying to draw the graph. Because 2 days of graphing so far, I've given you two different methods to solve these or draw these graphs. So when there's not a b term, when it's just ax squared plus c, okay, what we're looking at doing is just understanding what the a does, what the c does. Okay, c moves the whole graph up by 1. There's no number for a, so a is just 1. So it's not gonna be upside down or anything like that. What we did first, I didn't tell you this is what we were doing first on that 9.1 day, but we're going to find the vertex first by plugging in 0. I told you on that first day in your T-chart, just put 0 toward the middle, and I said, trust me. And the reason I did that is because what we were finding was the axis of symmetry. With ax squared plus c graphs, the axis of symmetry is always x equals 0. You basically are finding the vertex, which is also the y-intercept. They end up being the same point. So then we just chose numbers around 0. So 1 and negative 1 would give you the same answer. So 1 squared plus 1 is 2, which is going to be the same as negative 1. And then negative 2 will give you the same as 2. 2 squared plus 1 is 5. So this would also be 5. So that's how we started off. We just plotted those points. It should look like the x squared graph, but everything is just moved up one space. That's what the plus 1 does. Okay, then we'll go down and answer domain and range. The domain of this one is all real numbers. For range this time, we're going to use greater than or equal to. For problems that have a minimum, for smiley face problems, we use greater than or equal to. Because everything will be bigger than this number here shortly. The smallest y ever gets is 1, 0, 1. Then yesterday, 9.2a, we talked about how to graph if there is a b term. So this one is in the form ax squared plus bx plus c. Okay, and what we had to do is kind of memorize that formula for axis of symmetry. It goes like this, negative b over 2a, okay? And that helps us find where the vertex is because it's not just at 0, which is actually kind of good news for us because then we get another point for free. So before we get too far, we're just going to write down, okay, a is negative 2, b is positive 6, c is negative 1, okay? So when I find the axis of symmetry, I'm plugging in negative b over 2a. Oh, sorry, your notes are different than mine. This should be a 3. My apologies. Okay, this should be a 3. Your notes are different than mine. And that actually makes this a nicer problem. So negative b over 2a. Negative, we have 6 for b. 2 times a was negative 3. So we have negative 6 over negative 6, which is positive 1. So the axis of symmetry is at x equals 1. Okay? I know that that means that the vertex, the x-coordinate of the vertex is at 1. When we found the axis of symmetry, we just found a line that goes right down the middle of the parabola. It cuts right through the vertex. So what I need is the y-coordinate of the vertex, and I get that by plugging in 1, because 1 is the x-coordinate of the vertex. So negative 3 times 1 squared plus 6 times 1 minus 1. Okay, that gives me negative 3 plus 6 minus 1, which should give me positive 2. So at the vertex here, I'm at 1, 2. Okay, the y-intercept is when you plug in 0. What you get out is whatever c is. The y-intercept is always at 0, c, which is equal to 0, negative 1. So let's get those 2 points down. We have to graph one more point, but we want to make a good decision here. So I know the vertex is at 1, 2. I know that the y-intercept is at 0, negative 1. I also know that my axis of symmetry goes right through here, which means I already have this point, which is like 1, negative 1. So I need to choose a different point. I know yesterday, a lot of the time I said it's a good idea to plug in 1, but we already have 1. Okay? That's what the vertex is. And then I'm not going to plug in 2, because here at 2, I'm at negative 1. So this point here. So I already have that. So maybe I'm going to try to figure out if I plug in 3, what comes out. So I'm going to say, what do I get when I plug in 3? So let's do that. Y is going to be negative 3 times 3 squared plus 6 times 3 minus 1. That gives you negative 27 plus 18 and minus 1. So it looks like I have negative 28 and 18. So negative 10. So I chose 3 because I already have answers for 0, 1, and 2. So now I'm just going to the next smallest one I can, which is 3. It's all the way down to negative 10. This is 2 spots away from the green line, so I need to go 2 to the left of the green line. And there's my 5 dots. Okay, a skinny frowny face, which is what we should have had with A being negative 3. The domain is all real numbers. Don't get that wrong ever. And then the range is going to be less than or equal to this time, since we have a maximum. The biggest y ever got was right up here at 2. So that's a quick review of how those graphs worked. You just need to keep getting practice with those. They'll get better and better. Okay. Now what we need to discuss is, if it's a word problem, what that word problem might be looking for. So they're asking for the height of a thrown or tossed object. So when you throw an object, so here's me, I'm throwing a football. Okay. When I throw it, it's going to go up, 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 and then it's going to go down, 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 down. This is a parabola. Okay. When I'm throwing this, it has a maximum, which I could find as the vertex. Okay. So that's where I'm starting with this idea here. So a couple things. This equation is going to be important, but you don't have to memorize it because it's going to be given to you every single time, and I'll talk more about that. But in this equation, there's some letters you should know. So H is going to stand for height, how tall or how high above the ground the football is. T stands for time, so how many seconds since the ball was thrown. So you could plug in how high is the ball 5 seconds after it leaves Mr. Monahan's hands. V is for velocity, so this is initial velocity, or like the starting velocity. It's how hard I throw it. The ball is going to go higher if I throw it hard, right? And then C is it's constant. This is like the initial height. So how high was it to begin with? If I'm 5 feet tall or if I'm 6 feet tall, it's going to make a difference. Okay. Where does the negative 16 come from? This comes from the gravitational pull. This is just gravity. Okay, this is a constant for gravity. Ask your science teachers where the negative 16 comes from. It's how fast things accelerate toward the Earth due to the gravitational pull. Okay. Note, any word problem that asks about the maximum or the minimum an object reaches is a fancy way of asking for the vertex. These are find the vertex problems. So technically, a word problem should be a shorter problem than a graphing one, because you don't have to actually draw the graph. You just have to do the first step, which is find the vertex. All right, example 1. During halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched from a height of 5 feet with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. Okay. Go through and try to write this equation then. Remember that the equation had the form that started with the negative 16. So h is going to equal negative 16 t squared. That part's always going to be part of the equation. Nothing will change there. The next part is about how fast the t-shirt was shot out of the slingshot. It has an initial velocity of 72. So this is our 72t. And then what was the initial height? It was launched from a height of 5 feet. So we would put plus 5. Okay, this number, how high it was caught above the court, isn't going to do anything for us right now. Okay, how long will it take to the t-shirt to reach its maximum height is the first question. How long will it take the t-shirt to reach its maximum height? Think about it. What that question is asking is, what is the x-coordinate of the vertex? Because here's my t-shirt getting thrown in the air. Okay, left to right on my graph here, this is time, however much time passes. Okay, and then up here, this is like height, how high it is. Okay, so if I want to know how much time it takes to get to the maximum height, well, here's the maximum height. We talked about finding that vertex with negative b over 2a. This is the point t comma something. Okay, what they're asking for is what is the sorry, the bell's going off here. But how long will it take the t-shirt to reach its maximum height? What that's really asking for is what is the axis of symmetry? How long does it take to get to the top? That's just asking for the axis of symmetry. So instead of x, I'm going to use t, but it's going to say negative b over 2 times a. Okay, well, b is 72 right here. So negative 72 over 2 times a, which is negative 16. Okay, you should always get a positive answer for this because you're not going to get negative 5 seconds as an answer. That's not going to make any sense. We have negative 72 up top. We have negative 32 on the bottom. So we're going to get a decimal, but that happens with word problems all the time. No big deal. We're going to get 2.25 seconds. So it's going to take 2.25 seconds to get to the highest point that it will get to. Then the next logical question is, how high above the ground is the shirt at that point? So this step is just going to be plug in t. We just found what t was, 2.25 seconds. Now we're going to plug it into the original equation. H will equal negative 16 times 2.25 t squared, or 2.25 squared, plus 72 times 2.25 plus 5. Make sure you're careful with your negatives, but when you plug all this stuff in, you'll get your answer for how high above the ground the t-shirt is at that time. Okay, when I did it, I didn't get a decimal. I got exactly 86 feet. We're going to cross off part or number 3 here. I'm not going to ask you that. Again, it's just talking about what's the highest the t-shirt gets, what's the lowest the t-shirt gets above the ground. Okay, but this is going to be the word problem process. It's real. These are just find the vertex problems. Here's another example. Okay, example 2. Daniel kicks a soccer ball up into the air with an initial velocity of 64. So this is going to be like our B term. The ball is 2 feet above the ground when it is kicked, so that's like our C term. So our equation, H equals, the first part never changes, negative 16t squared. The part with a t is the initial velocity, so this time it's 64t. And then plus 2, it's 2 feet above the ground when it's kicked. First question, how long will it take to reach the maximum height? So this is axis of symmetry. T will be at its maximum height. So again, here's my picture. Okay, kicking the soccer ball that's 2 feet above the ground, big foot. It's going to go up, 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 and it's going to go back down to the ground. Okay, this will be my maximum height. Remember, I'm looking at how long it's going to take. That's my x coordinate. So t is equal to negative b over 2a. So b this time was 64, so negative 64 over 2 times a, which is negative 16. I have negative 64 over negative 32, which is 2. So 2 seconds is t. Okay? It's going to take exactly 2 seconds for the ball to get to the highest point. How high will above the ground will the ball be 2 seconds after it is kicked? So we got to find the height. We're plugging in 2. Negative 16 times 2 squared plus 64 times 2 plus 2. Okay, this is negative 16 times 4, so negative 64 plus 128 plus 2. Okay, so I have negative 64 and 128. That makes 64 plus 2, so 66 feet in the air is how high it will be. That's the tallest that it can ever get. Okay, these are how the word problems work. If they ask you about the maximum height of something in a word problem, something being thrown in the air, it's going to be find the axis of symmetry first, and then plug that value in to figure out how tall the object gets. Okay, moving on. Oh, that's going to be it. So perfect. So that's the last one for today. As we go through then, go ahead and try a couple more of these word problems, and there'll be some more of the graphing ones as well. You guys are ready to try the assignment. Thanks for watching.